Everyone, Mr. Smith here, coming at you with our first of four kind of shorter. Well, maybe one of them is not so short. This one's pretty short. Short lesson, either reviewing or previewing some skills that we're going to need in the grade 12 advanced functions course. Today, we're going to learn a certain notation for expressing a range of numbers called interval notation. So let's get started. You guys can be following along with the lesson sheet provided on Brightspace. So last year, when you guys were introduced to the idea of the domain and range of a function, you guys used set notation. Now, for a quick example of what set notation would look like, I'll use maybe an example of the sine function. Now, in a later review lesson, we're going to review different types of functions you learned. But, in grade 11, you guys were introduced to the sine function. Kind of looks like this. And if you recall, the highest the sine function ever got was 1, and the lowest it ever got was -1. And when you guys were describing the range of this function, what y values does this function hit? In grade 11, you were taught this notation. So if you want to say that y can be any number, any real number between -1 and 1. So we used curly Q brackets to indicate we're indicating a range of numbers. So we would say y, the y values are any real number. So this is the Greek letter epsilon. So it means like is an element of. So y is an element of the real numbers, or y is any real number such that. And if we wanted to say that y was between -1 and 1, we would say -1 is less than or equal to the y values, which are less than or equal to 1. This is a math way of saying, using inequalities, that y is between -1 and 1. This is set notation. We're going to introduce possibly maybe a nicer, more concise way of describing an interval called interval notation. And we're going to be mixing in both of these throughout the course. In later courses, you'll use both. It's just good to have both. Let's continue. When we use interval notation, we're going to be making use of two different kinds of brackets. And the brackets we use are very important. They have two different meanings. When we use this new type of notation, when we use round brackets mean we're going to exclude a number from an interval, from the interval. We'll see what this means more clearly in a moment or two. Square brackets mean that we include the number from the interval, or we include the number in the interval. That's better grammar there. We're in math, though. It's okay. So round brackets, you don't include a number. Square brackets, you do include a number. And just a reminder too, since you're watching this video on YouTube, if you find I go past a slide kind of quickly, you always can just pause to get things down, right? So let's continue. Let's put this into practice and dive right into some examples. So in these examples, I've given you, I'm just going to move my handsome face to the top right here. I've given you some intervals, some ranges of values in set notation at the left. This is the notation you were introduced to last year. What we're going to do is I'm going to show you how we can draw that range of values on a number line. This is a skill you may or may not already have. It's okay. It's a pretty easy skill. And then I'm going to show you what the interval notation would be. We're going to do this for a few, and then I'll have you guys try some. So here, this first example is saying x is any real number that is greater than or equal to 4. So how do we represent that on a number line? Because we are including 4, we're starting at 4, we're going to put a closed dot at 4, and then we just have an arrow going above 4 saying x is any number above or equal to 4. But because we're including 4, a closed dot. How do we write this in interval notation? we write it like this. We say x is an element of the range of values. So we are including 4. So the lower bound of this interval is 4, and is anything above 4. So for the upper bound of this interval, we're going to use infinity. So like the sideways 8, and we use a round bracket for infinity. So this is how we would express this range of values using interval notation. Arguably, a little bit more concise. Some people prefer one, some people prefer the other. They both mean the same thing. Now, I should tell you, and I'm going to write this in green, some resources might have the following as well. They might, just being a bit more formal, say, okay, x is any real number such that x is an element of the interval from 4 to infinity. Close it. I personally find that a little bit much. I am okay if you guys just do x as an element of the range from 4 to infinity, including 4. But yeah, maybe depending on the resource I pull practice from, or if you're looking at other things online, just a heads up, you may see that. But I think it's a little, just for our purposes, a little redundant. All right, let's switch back. Am I using navy blue or black here? I think, well, it doesn't really matter. All right, x, the next one. X is a real number such that x is less than 0. So how do we represent that on a number line? When we're not including a number, we use an open circle. So I'll put an open dot at 0, and then anything less than that, an arrow going down. This is showing or representing the range. Anything below 0, not including 0. The way we would express this in an interval, with interval notation, we would say x is an element of, and we think like, what is the lower value and what's the upper value of this interval? Well, there's really no lower value, right? X is less than 0. So just like we used infinity above, we use minus infinity for the lower value. The upper value is 0. Now, we are not including 0 in this interval. It's strictly less than 0, so we will use a round bracket for 0. This is interval notation. I'm quite confident you guys will get the hang of it very quickly. Let's continue and just look at a variety of examples, kind of cover all our bases, and then get you guys trying some. X is less than or equal to minus 2, so we are including minus 2, and an arrow going down. In interval notation, this would be, okay, our lower value, minus infinity. Our upper value is negative 2. We are including negative 2. So a square bracket. So I'm going to move on to a few more examples here. Feel free, if you think you get the idea, maybe pause the video and try the next ones on your own. Unpause when you're ready and just check out what I do. But I'm quite confident, probably already, many of you guys are feeling okay with this. But let's do a few more together. All right. So x is greater than negative 1. So not including negative 1, strictly greater than, open dot, and then greater than negative 1. So arrow goes that way. In interval notation, we would say x is an element of the interval. The lower value is minus 1, and just caught myself there. You can see I was using a square bracket. Bring up my trusty eraser here. You guys are going to notice I'm going to have to use that quite a bit. Often my head's off in the clouds thinking about grand things, and I miss the small details. This should be open bracket minus 1. And to infinity, anything greater than negative 1. So there we go. How do we treat a range of values between 2, not just greater than something or less than something? The next one, we have x is a real number, and this is between negative 2 and 2. And you'll notice we're not including negative 2 or 2. So open dot at 2, negative 2, excuse me, open dot at positive 2, and we're representing the range of values in between them, solid line. In interval notation, we would say x is an element of the interval between minus 2 and 2. Round brackets, open brackets, we are not including minus 2 and 2. All right. Again, I'm quite confident many of you guys probably have the idea already. I just have 2 more examples and then a little exercise for you guys to try. So let's continue. Here we have our range of values where we're including one bound. In this case, we're including the upper bound 4, but we're not including the lower bound minus 3. So x is any number between minus 3 and 4, but we're including 4, and we're not including minus 3. Solid line, joining those guys. Interval notation, open bracket for minus 3, close bracket or square bracket for 4. Now, finally, for some functions, you guys know like x can be any real number. For example, like the basic quadratic function f at x equals x squared. We all know what that looks like. Basic parabola, and we know that what values of x can we plug into that function. What is the domain of that function? Well, you can plug anything you want in for x. 0, negatives, positives, decimals, it doesn't matter. So the domain of this function would be x is any real number. This is how you would have written that in set notation. How do you write this in interval notation? If you want to pause the video and make a guess of that, feel free and unpause when you're ready. But we would write it this way. We would say x is an element of the range of numbers between minus infinity and positive infinity. So arguably, this is the one case where it might be a bit more writing to write that in interval notation as opposed to set notation, but that's how we would do it. All right, so I have a little exercise for you guys to see how well that sunk in. In this exercise, I've given you either the set notation, the number line graph, or the interval notation, and asked you to do the remaining, find the remaining two. Now, at this point, my preferred practice would be doing a video lesson. If I'm asking you to try something, pause the video and give it a try. And when you feel like you're ready or you need a hint to get unstuck or whatever, then play the video, or just if you just like to play the video and just follow along with me, you can do that too. But I would strongly encourage you to see if you get the idea and try it yourself. So that said, pause the video, unpause when you're ready. I'm just going to go through these. I won't do them too quickly, but I'll move through them at a fairly good pace in case you're taking these up. Remember, you can always pause the video if you just need a moment. So x is less than 1. So these are cases we've learned how to handle. X is less than 1, solid line, anything below 1. Interval notation, x is between minus infinity, always open bracket, always round bracket, and 1, round bracket, we're not including 1. Greater than or equal to negative 2, solid dot because we're including it, arrow moving forward above it. Here, we're including negative 2 as a lower value. Anything over that going to positive infinity. And finally, we have a range between minus 4 and minus 1. Minus 4 is the lower value. We're including it. Minus 1 is the upper value. We're not including it. Solid line. In interval notation, lower bound is 4 included, square bracket. Upper bound minus 1, round bracket. Excuse me, I think I said 4, minus 4. In the next several, I believe I give you the interval notation, and we're going to work backwards. So give this a try. So what is this saying? X is between 0 and infinity, and we're not including 0. So on a number line, the lower bound is 0, don't include it, open dot, and up to infinity. So a line like so. In our set notation, this would be x is any real number such that x is greater than 0. So if you got that one, good for you. What is this next one saying? X is between 2 and 5, but we're not including 2. We are including 5. In set notation, x is any real number such that, and we would write when we have we're doing between two values, this is how we do it. We would have 2, and 2 is not included, so strictly less than x. We are including 5, less than or equal to 5. And then finally, minus infinity to 3. So 3 is the upper bound. We're at square bracket, we're including it. And is anything less than that? In set notation from last year, we would say x is any real number such that x is less than or equal to 3. So if you got those guys, again, great job. If you didn't, maybe go back and have a look at the examples we did and try these again. Just let it sink in. For most of you, this will be some new notation, and it might take some time to sink in. All right, finally, for this last three, I've given you guys a number line graph and asked you guys to do both the set notation and interval notation. So here we can see x is between -3 and 3. We are including -3. We are excluding +3. So x is any real number such that -3 less than or equal to x. We're including it. We're not including +3, strictly less than. Here, x is 1 or above. We're including 1. So square bracket on the 1. The upper bound is infinity, always a round bracket on our infinity. And in set notation, we would say x is any real number such that x is greater than or equal to 1. And finally, in our last one, it looks like x is anything less than -2. We're not including -2. Lower bound, negative infinity, always round bracket. To -2, round bracket. And here we are saying x is any real number such that x is strictly less than -2. All right, so hopefully you did well with those and got the idea. Hopefully I didn't make any mistakes in there, didn't catch any. I think it looks good. Just FYI, moving forward throughout the course, it's going to happen. I'm going to make a silly mistake. I'm going to say 2 + 2 is 3 or something dumb like that. And it happens to everybody. Just if you notice a mistake in any of our videos, especially because I'm shooting the video content for this course for the first time, please let me know and I can make a note in the description or something like that. Okay, what's up next? So in our next lesson, we're going to review the types of functions you've encountered in grade 9, like linear functions. In grade 10, you did quadratic functions. In grade 11, you exploded the types of functions you've seen: exponential, square root function, rational function. So we're going to review the types we kind of should be familiar with coming into the grade 12 functions course and tie in applying interval notation to stating their domain and range. So we'll review some basic types of functions. What is their domain and range? We will use interval notation. There is no attached practice for my grade 12 functions course for interval notation. This is a short mini lesson to kind of get you up to speed. So yeah, until the next video, I hope you guys are staying well. Have a great day, and we'll see you soon.